you all for being here. It's nice to be down here with you. My name is Anthony Dente. I'm a civil engineer, number 80,750. The old edition. This is all going to be about structural engineering now. How many structural engineers do we have in the crowd? Wow. How many are signatories on SN 2050? My coworker Holly is here. Hi, Holly. Thanks for coming out. She's our well-rested. Well, we're structural engineers. We believe green engineering is good engineering. Efficient material use is our goal. And these are to some more of my team members, which anything I say I on here, I mean I couldn't do without this team. And we, he's studying the slides. I need you to remember that. Sorry. Yes, please. So we work on everything from pretty small residential up to mid-rise mixed-use commercial. I grabbed this slide. We're normally talking about our alternative work, but there's, our 4.5-story building in Berkeley, mixed-use commercial structure. But one of our specialties is alternative materials, materials that in my beginning of my career weren't codified, but we want to see more of these buildings built, low carbon, natural building systems. And so going after permits, we found we've needed more research through the years. We teamed up with a number of universities. Santa Clara was one of our first relationships. Who I was just on a call with some of their students on the way down here. David was gracious to listen to that while he drove. Thank you. We ended up with a bulk of research on some of these subjects, and so we got into some code development work. I'll talk about that too. But I'm mentioning these things in case any of it sparks your interest and want to talk about it afterward or have a question on these subjects. We have our hands in this world. And from our material work and permit acquisition work and research work, we're finding ourselves being called by a lot of companies that are trying to have good, green, innovative ideas. And so I'll talk about a few of them. Two of them are in this project here. Next slide. Actually, could you go back for a second? So here's your straw bale work. This Adobe project down in Topanga. Cobb, which is a monolithic Adobe form. This is in Berkeley. This is Esalen Institute with Architectural Architects down in Big Sur. Innovative wood space, a cool project. Some more straw bale. Next slide. We have some rammed earth work, and in some of our first steps into custom prefabricated straw wall panels. This is a residence up Healdsburg area with a straw mixed with wood construction mixed with rammed earth CME unit. Some bamboo work we did in Nepal, some earthquake relief examples of Builders Without Borders, just some of the breadth of materials we work with. And, as a structural engineering firm, as a structural engineering firm, we had the opportunity to be consultants on many materials, and it benefits us to have our hands in all of it. We learn a lot. They're similar in certain ways and different in others, whereas some contractors, some architects, it's important to focus on one material, but it's something that as structural engineers, I feel like is a great value of just that's inherent in what we do. Okay, now please. I mentioned that we got started with custom prefabrication straw, and over the past 2 years, we were working with the EPA on an SBIR grant, Small Business Innovation Research Grant, to develop a very sizably sound insulated straw wall panel of our own. I'm going to be talking a lot about Eco Cone today, which is an excellent product, and there's new frameworks and Croft, and there's some other examples on the market. This is the Burden panel, my second company, Burden Building Products. We're solving the problem in a different way, and so we're in development, kicking off beta with this. We're actually doing a seed fundraising round right now. If any of you know people or are personally engaged in equity purchasing like that, please talk to me. We've kicked off the round. We have our first advocates, but we're in it right now. So any help you can offer on that front is much appreciated. But we're thinning out the wall panel, and that's one of our biggest innovations by optimizing the material implementation, the straw itself, and the matrix of it. Next slide. I'm also on the Cobb Research Institute. I'm vice president, and Cobb is a monolithic Adobe material. I can talk more about that, but it's not a feature in this project today. With that organization, I was the lead engineer for the Cobb or monolithic Adobe appendix in the International Residential Code. And with our research there, we just finally came out with this book in January. And if anybody wants more information on mass wall systems. This has all the cutting-edge research we've been working on over the past 15 years. And so we just checked it out. Matt, to this project. I'll start with saying that it's great to work with wonderful collaborators. I'm sure you all agree. I'm not telling you anything that's rocket science there. Committed, caring designers, builders that are really engaging with the design and understanding the intent, and a committed client that's wants to make the good things happen. All ends up mixing up into a great opportunity that we like to work on. And projects like this is what help us get up and get to the office every day. I'll start with the concrete. We mentioned the concrete, and they're bigger than I'm happy to show the Ashland project there. One big thing about that project is it just didn't have as much concrete. It didn't have a basin. It didn't have retaining walls. It didn't have retaining walls that had to act like they were in a lake. And it did have a relatively similar cement content in its mix, though. But volume matters. And I want to highlight cement content in the mix because we find ourselves talking about, well, how much fly ash did you have? How much slag did you have with 70%? And that is a means to an end. The end is decreasing the carbon emissions from the Portland cement in the mix. So I really try to focus on that Portland cement content. And that 155 pounds of cement per yard is a very good number. Our lowest numbers get down to 100. I was involved with the working groups that developed the Marin County's low carbon concrete building code. It's the first in the world of that type, and the Ecological Building Network forwarded along with the Carbon Leadership Forum. But if you don't know that code exists, check it out. It's a great code. It's always interesting being in code development and seeing you start out with a very complex problem, and I do believe your group got to a nice, succinct, digestible first step on navigating the delicate dance of reducing Portland cement, which is obviously a major industry globally. Next slide. Let's see next slide. This is the Marin County low carbon concrete building code. This is the main section of it, where you see that up to 3,000 psi concrete, the Portland cement per yard, 410 is what they recommend. And if you recall on my last slide, we had 150. And so this is them trying to limit, and some were going to 600, and we're down at 150. So it's a big step forward. We need to get to zero, one step at a time, until we all, melt. But yeah. So straw construction. I moved out of Pennsylvania about 15 years ago to practice straw bale structural engineering under Kevin Donahue, structural engineer. He's now my business partner, our senior engineer. But we've engineered just about every way you could think about putting straw in a building. And laying bales flat on the ground and using a reinforced plaster system is the most common. And though it's labor intensive. So you have parties, but sometimes, not everybody has the opportunity to have that. The walls are thicker, and your engineers involved with your mesh, the tilling and plaster. So, there's got to be a better way. Why don't we use plywood? There used to be a larger concern about plywood over bale walls for moisture exchange, and a lot of roofing modeling that Davis Projects, along with Dan Johnson of Beyond Efficiency, a building science engineer, have opened the door to us using more plywood. So now we're seeing folks, which is actually on the next slide. We're seeing folks. So this reinforced plaster system, very common. You lay bales flat, you can put them on edge. Now we're finding ourselves doing a lot of this, put bales on end, get between studs of 24 inches on center and putting plywood sheathing over them. It's still pretty labor intensive, and we're working out the kinks. It's like a odd wood framing system. And that's what kind of gets us to the point of these prefabricated panel ideas, because the oddities of trying to fit straw into conventional practices takes another step back, and we're just dropping these off at the doorstep. And if you go back one slide, I mentioned Appendix S here. This just got a new title in the International Residential Code, but For the past, I don't know, 10, 15 years, there's been a group of us that have been entering these alternative materials into the appendix of the International Residential Code, which turns into the California Residential Code for anybody who doesn't know. And we're working on getting all those adopted into California. I could talk to you about that, but there's hempcrete, there's tiny homes, there's straw bale, there's cob. We're advancing the Adobe Code, which was in the IBC with a committee in the TMS, the Masonry Society, which is the main masonry reference code. But just that these codes exist. White straw clay also has appendix. And now let's go next. This project, happy day to share the architectural floor plans. This is a presentation by a structural engineer. My drawings are not going to be as nice. But just because we have these nice panels showing up doesn't mean things aren't complicated. This is a nice custom design, and it has the complications of those Palo Alto issues. And so we have a number of different top plate, floor plate, elevation concerns, and these things are coming in from Lithuania. So you don't want them to show up an inch shy. And even though a short earth tone would be the right solution to fix that, but there's a lot of back and forth and attention being paid there. And I want to highlight that because that's why we give presentations like this that maybe not show total warts and all, but if this is not necessarily just because we're getting out of bale by bale construction, it did add time in the office for sure, in collaboration with them, preparing models, making sure things were all lined up, making sure that your hold downs from your second floor, which might end up on a straw wall. Like in this case, the second floor walls ended right here. And so we had hold down straps coming down to that economic cone wall down below and just making sure they were going to have a stud in that panel right there so that they could receive the strap, things that were very important. I lost sleep over it, kind of. The rammed earth panels that I mentioned, Rammed Earth Works has been a company doing rammed earth construction in California and beyond for a long time. Dave Easton ran that company. He passed away very unfortunately to all of us in the community not that long ago. But he was developing both a CMU rammed earth equivalent, but also these rammed earth panels. And Burton's been doing engineering with the panel company to help them optimize how it's connecting to the building. It's just generally a facade, complements a cladding element. It's a non-structural feature, but still has structural consequence. And it's very beautiful, and offers an opportunity to have a rammed earth look at your house without that kind of space. They do stabilize these mixes, which means they add cement, and the whole urban building community is, always exploring the right stabilization for the right mix, and I can talk about that for a long time, but I won't unless you ask. So, it's not the easiest plan to read, and Kurt Found has been very good at navigating it. Yeah, I know. And so you play this on the I'll blame it on Dave, I'll blame it on Palo Alto. But really, you can see this wall is set back, lower wall down below. Same thing happens over here. Berry wall down here. Those are stacked. These are stacked here. This roof is coming in, sloping and meeting partially up this wall, while its connection to this wall. We have this is a lower garage over here, and the collector line to the shear wall back here has to navigate the space that the ceiling height in the lower portion is off. And so we're navigating all these things while trying to keep the environment in mind. Back here we have a very large opening for access to the back. Nice sun. It's a good sunny angle. Next slide. We ended up putting a moment frame in there, which is a system, not commonly used in residential construction, but it has, it's versatile. It opens up a space, and it also has a very high response modification factor. So it's a measurement of ductility in a lateral system, and the reason that it's important. mass times acceleration equals force. And we have wall panels in this building that are more massive than usable. And so we have more seismic force to deal with. It's also a decent sized residential building. And the way that the code has you account for how much of your mass transmits into earthquake force, demand force, is accounting for the ductility of the lateral system you're using. And if your lateral systems are stiffer, then more of your force, more of your mass translates into force. And your stiffness of some wall lines can affect how much force other wall lines get. So if you just need to change one wall line, it's nice to change it to something that has a large response modification factor. We have ductile, we have flexible floor diaphragms as structural engineers, and I can get into this but sometimes we have to idealize as rigid and this and that. But there's also this kind of minimum sizes these things go down to. And so this looks quite large to some people, and it might be inherent because it's commonly used on larger construction elements, but it's a versatile system. It does actually have green benefits, and those are the ones that I just mentioned here. As much as it seems like you just dump it, steal the project, it's well thought out. Here's some lateral load pack collection lines of differing heights. Here's that one sloping roof that actually meets slightly up the one wall, while we have this other floor diaphragm coming in, collecting that wall and getting it there. Just some unique aspects of this project. But next, other interesting connection details. Happy to talk more about the funky things about them, but I might have shared enough, and I think it's time to pass it on to Dave. So thank you all for listening.